Hello world, Lisa Fredrickson, your friend and professor from Johnson County Community College. In this short screencast, we're going to talk about the math order of operations and why we care about this in the first place. First of all, let's define some terms. The math order of operations question is, what order do you evaluate formulas that have more than one operation? The operations themselves include addition, subtraction, multiplication, division, and exponentiation. A mnemonic to remember the order of operations is PEMDAS. Please excuse my dear Aunt Sally. And each of those letters represent the order in which we have to evaluate a formula. I did not make this up. It's just a rule that I've had to learn and live by. This rule applies to every formula you're going to encounter, from algebra to JavaScript to Excel to Java. Every program follows these same rules. Fortunately, once you learn PEMDAS, it applies everywhere. The P stands for parentheses. Evaluate them from inside to out. The E, exponentiation, when we take a number and multiply it by itself. The third rule is multiplication and division, which are actually the same operation, multiplying or multiplying by 1 over the number. And then we have addition and subtraction, going left to right, adding a number or adding a negative number. PEMDAS. But backing up just a second, why do we care in the first place? Why do we need to learn this? Well, we need to learn it to solve word problems. But you may be saying, I hate word problems. Fortunately, you're in college now. You're much older and wiser than the last time you tried them, and life is full of word problems. So let's try a relevant example. Case 1. You and Joe plan a party. You invite 20 people, Joe invites 15. You have a budget of $10 of food and drink expense per person. What is your total budget? Well, you can probably figure this out in your head. It's going to be $10 per person times the number of people you have, which is 20 plus 15, right? So here's the formula, 10 times 20 plus 15. And right here is where the difficulty comes, because although you can figure this out in your head, 20 people plus 15 people is 35 people. If you invite 35 people and spend $10 per person on each person, then you've got a budget of $350. We can just do that right in our head. Well, unfortunately, a computer is much dumber than you are. It has to have everything spelled out. And when you put any formula in a computer, it does not know if the answer is correct or not. You have to put it in such a precise way that it knows exactly what to do. So let's evaluate this formula without knowing anything about the order of operations. Going from left to right, we would take 10 times 20, which would be 200, and then we would add 15 to 200 and get 215. That's how a stupid computer would figure this out. Is this correct? If we said yes, we need to think about our problem a little bit more. We have 20 people at $10 per person, and that's already $200, just the people we're inviting. So how does Joe get to invite 15 more folks for only $15? Of course, this is not correct. So let's click no. $215 is not the right answer. So what is the problem? The problem is we have to find the number of people before we multiply that by $10 per person. So to use this formula, we would have to add parentheses to force the addition to happen before the multiplication. So the correct formula would be $10 times 20 people plus 15 people. And if we go really slow and break this out step by step, here's how a computer does it. It does it in 4 steps, the order of operations. A computer thinks about it like this. It evaluates the parentheses from inside to out. So $10 times 20 plus 15 becomes 10 times 35, because this has to be done first. Step 2, it looks for exponentiation. Fortunately, there is no exponentiation, so we go to step 3. Step 3, we evaluate multiplication and division from left to right. So 10 times 35 now becomes 350, our correct answer. Step 4 is addition and subtraction from left to right, but we don't have to do this because we've already arrived at our answer. So we need $350 for this party. Maybe we're inviting too many folks, haha. So the reason I'm going through this in excruciating detail is because this is exactly how a computer thinks. It slows every process down, and for every single formula, it's going to go through these 4 steps. So we have to think like a computer if we're going to program a computer. Let's take one more quick example. Pizza delivery. You get paid $50 per shift. You also forecast $5 tip per delivery and 10 deliveries each shift. How much money will you make in a shift? Now you're smart, you're a human. You're going to say, $5 tip per delivery on average, and 10 deliveries, that's $50. Plus I get paid $50 for the shift. Right away, in your head, you've come up with $100. But again, the computer is not nearly as smart as you. The computer is going to have to break this down into a formula it can evaluate. And so it starts out like this: $50 per shift plus $5 tip times 10 deliveries. And if we do not know anything about the order of operations, here's what happens. $50 plus 5 times $10. $50 per shift plus $5 per delivery times 10 deliveries, correct? Well, going from left to right, we would get $50 plus 5, which is $55, and then multiply it by 10, $550. Is this correct? If I say yes, well, of course not. Let's think about this. A $5 tip for 10 deliveries is only $50. So how did we get to $550? We got to $550 because we're calculating it incorrectly. So let's click no and look at the correct answer. Unfortunately, it's difficult to make $550 a day delivering pizzas. We know that. We're smart. We're humans. But the computer is not smart. It's going to do exactly what we told it to do. So we need to tell the computer to find the total amount in tips before we add that to the $50 shift. In this case, if we built this formula, we would not need the parentheses, because we've learned by PEMDAS that multiplication is done before the addition. So simply writing this formula out without the parentheses would actually calculate correctly in the computer. However, look how those parentheses clarify what needs to be done first. So the moral to this story is, when you're writing a formula in a computer language, you can use parentheses. Sometimes they're needed, but sometimes they're just used to clarify for our human brain what is happening first. And let's think about this as a computer thinks about it. Step 1, evaluate the parentheses from inside to out. So 50 plus this becomes 50 plus 50, because this is calculated first. On to step 2, no exponentiation. Step 3, there's no more multiplication or division. So step 4, evaluate addition and subtraction from left to right. And we've got 50 plus 50 is $100. So we're making $100 per shift delivering pizzas. I know what you may be thinking at this point. Remember, you are much, much smarter than a computer. A computer program needs every little step carefully planned and executed. When I'm working with my students in JavaScript and their JavaScript is not running correctly, which happens all the time when you're learning programming, that is my main thing I try and get the students to do, is break down the steps and look at every single little step. Make sure every step is executing exactly as planned. So you have to take your enormous, wonderful human brain and break it down and think like a computer, which takes one little tiny step at a time. If you find brain puzzles like this fun, you're definitely in the right place at JCCC. Come to the Web Development and Digital Media program. It's really kind of fun. And if you want to practice on this, I've built a little web page here where we can take numbers 2, 3, 4 and do different operations on them. I'll do exponentiation, 2 to the third power, and then I'll subtract 4. 2 to the third power would be 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. 8 minus 4, my guess is 4, and I got it correct. If I had answered something incorrect, I just get to try again. So you can keep practicing these order of operations for as long as you want until you're sure you've got it. Thank you for listening.